We want to understand the solar system, understand the stars, and how the universe was created.
How can life exist in places where it was thought impossible just a few years ago? Water had to appear in the history of the Earth. It might have fallen from the sky. The possibility that life arrived on Earth from Mars, for example, is not absurd.
Well, the final goal behind all of this is to find the origin of the universe.
The lesson we have learned is that whenever life has a chance, it adapts.
To understand the origin of the first stars and how the universe evolves will allow us to know how we became what we are.
We set out on a journey in search of our cosmic origins, on a fascinating voyage that will take us back to the distant past of the universe. In search of the first galaxies and stars, as well as the origin of life. We will visit the world's most advanced observatories and try to reconstruct the beginnings of the cosmos. How did water arrive to our blue planet? Is it possible that we are all children of Mars? Our first stop in the search for our cosmic origins takes us to the Araucania region in the south of Chile. We visit an indigenous community of the Mapuche to share in their celebration of the Way Trapanto, or New Year. It coincides with the winter solstice in the southern hemisphere in the month of July. During this season, the earth begins to cleanse itself with rainwater, beginning a new cycle.
Mi padre Lorenzo Ayapán Cayuleu, el hombre pájaro Ñumche.
My father, Lorenzo Aypan Koyulu, the birdman, or Yumchi, is a kimchi, a wise man. He is with us today to teach us about the Huchu Pantu, to explain its vision, how to feel it, how to dance it, how to take the energy from the Mapu. This is a cycle, a change that has to do with the moon, where the whole process begins. Trees turn green, the days begin to get longer, and the productive cycle starts. People begin to plow, to sow, to have their flowers, their seeds.
a tener sus flores, a tener sus semillas. Y esta es la época donde uno planta por todos lados.
This is the time of year where we plant and things grow.
Lo que tú hagas crece.
Whatever you plant grows as long as you do it with nigual, your respect, and you say your prayer to the plant so that it grows.
Mai fa mai len mo architecture o len mo tamangen ka fe amolen mutipanto la rume el kunuinya pu mongayel pu kure punyawe feliker kan kamsengo.
There is what we call a resulting occurrence. Just as we are born, we die. In these resulting occurrences, it turns out that the human being lives with his family, has his ancestors, has his relatives, and upon dying, he leaves behind a good experience. There's a type of inheritance that he leaves his family so they may continue on the same path, the same legacy throughout time. This is a very old custom, a tradition that we celebrate. There's a beginning and an end. The beginning starts now, on June 23rd and 24th each year, where we celebrate, and on the following day, the purification. In a stream, if there is a stream, or in a river, or an ocean, we bathe and purify ourselves. Yes, there's also a ceremony which refers to the Wuchu Panto, which means something like invoking, celebrating, good weather and new hopes.
Some 1,200 miles from this ritual celebrating the birth of a new life cycle, we witness a completely different scene. In this area, ALMA, the world's largest radio observatory, is dedicated to revealing new clues about our cosmic origins. Together with astrologist and National Science Award winner Jose Massa, we visit ALMA. Jose has discovered more than 100 supernovas, which correspond to the violent death of stars, a wondrous process that gives way to the fundamental materials needed for life.
Aquí estamos viajando al sur de la ciudad de San Pedro de Atacama.
Here we are, traveling south of the city of San Pedro de Atacama, heading towards the largest observatory on the planet today, which is the radio observatory ALMA, which is located on the Chilean Plateau, 5,000 meters above sea level. This radio observatory will seek out the cosmic origins of human beings. By this, we mean the formation of stars, planets, galaxies. It's the most advanced radio observatory, and we are now headed towards the technical part, the offices of ALMA, which are located 30 miles south of San Pedro. Here we are, with the last of the antenna being delivered to the ALMA project. In total, they are 66, and this is the last one, which was just assembled. This antenna, despite its large size and its huge mass, moves with the precision of a clock. It points to stars, one by one, and it's going to give us extraordinary data when it's taken to an altitude of 16,000 feet, where the 66 antennae of the ALMA project are going to be installed.
Now we are going to go into what we call the base of the antenna.
So, esto se llama...
See, this is called the cable wrapper because when the antenna is going to move, all the cables need to rotate with it. Because the antenna moves from one side to the other, and everything must move smoothly.
Porque la antena se mueve en un lado, después se mueve en el otro lado. Todo debe estar smooth, se debe mover, todo suave.
This is the fiber optics line. For now, for our test, this is going to be like this. The fiber optics line is going to pass down the middle here.
So, 100 tons of antenna end up here, in this fiber optics line that gathers the data?
Hace 60 años,
60 years ago, we began looking at the sky through radio waves. And in order to detect objects that only emit radio waves, we need a very particular antenna. This one behind me is 12 meters in size, with extraordinary sensitive receptors. And 66 of these antennae, working together, like in a synchronized dance, are going to discover, in the upcoming years, the origins of the solar systems, the origins of the stars, and how the first galaxies of the universe were formed.
Today we know that our world contains thousands of millions of galaxies of various shapes, sizes, and colors. It's a true cosmic sanctuary. Galaxies, in turn, are made up of gas, dust, and countless stars that illuminate the sky. What is the origin of this rich and varied material that culminated in the formation of life on our planet? To answer this question, we have to travel back in time. To be more exact, we have to go back some 13.7 billion years when the Big Bang gave life to time and space. Some 400,000 years later, the universe cools and forms the first atoms, which in turn, millions of years later, unite to form the first stars that illuminate the universe. Those stars are the seeds of the great structures that populate our cosmos today. The ALMA Observatory is home to people from all the continents. Culture and language take a back seat to the great mission that joins all of its researchers.
One of the most incredible things about the antennae is the precision of their surface, which is 1/1,000,000. So most antennae have a diameter of 12 meters, 40 feet, and the precision is 12 microns. If we had, for example, a soccer field, which is about 100 meters, the precision would be 0.1 millimeters, 4 thousandths of an inch. So we can see that the surface of each antenna is extremely precise. This means that when the signal arrives, it will do so in the best way. The presence of the Andes mountain range affects the way in which the antennae point toward an object. So we have to correct for this effect because the mass of the mountain range and its gravity pull the antenna to one side. ALMA is an incredible project for all astronomers. We are going to redefine the term millimeter astronomy because we have many antennae at 5,000 meters. That's 16,000 feet. So we are expecting many new discoveries in all areas of investigation. Among these, the birth of stars and planets, close galaxies and distant galaxies, cosmology, and many surprises.
ALMA has already delivered a wealth of knowledge. This is the first image obtained by the Radio Observatory. It's a look at two spiral-shaped galaxies named antennae, located some 70 million light years away. ALMA has allowed us to cross debris-covered zones in order to capture clouds of cold, dense gas, visible in red, pink, and yellow colors. This is where new stars are being born. In an unprecedented discovery, ALMA has also helped discover sugar molecules surrounding a young star whose mass is similar to that of the Sun. These sugar molecules are a basic component of life. For the first time in history, here, we can see tremendous gusts of gas coming out of a young star. ALMA has just begun its exploration of the universe, and cutting-edge technology is playing a crucial role.
This is Otto, one of two transporters that moves the antennae in the ALMA observatory. They are one-of-a-kind machines built in Germany exclusively for the observatory. They have everything technology has to offer: hydraulics, pneumatic motors, computers, laser and ultrasound systems, everything. It's not easy to manage because it's more than 30 feet wide. One has to be very careful along roads, people driving around curves. If we did crash into something, we probably wouldn't even notice because of the weight of the machine, 130 tons. In general, we begin to use oxygen after about 17 miles to avoid any possible issues like fainting. And in general, over 16,000 feet, the process of thinking is slower, so oxygen helps us to be alert and aware of any problem we might have. We have to be able to resolve these quickly, and oxygen helps. Only 4 operators are trained to move this machine. What ALMA does, what the antennae do, the transporter is very interesting and a great challenge. Well, the final goal behind all of this is to find the origin of the universe, which is what we eventually expect to discover.
I'm really excited to be here. I was here 15 years ago when this was just a plan, when the land was pristine. There wasn't even one antenna, and now, to see 58 antennae, it seems like a miracle. I thought I was never going to see this while I was still an active astronomer. And today, it's a reality before I even retire. This is the most powerful radio telescope in the world. Astronautics and the exploration of the moon, and now vehicles exploring Mars, trying to understand the solar system, understand the stars, how the universe originated. How was it that, starting from nothing, everything exploded and galaxies began to form? And in them, stars and planets. I find this marvelous, and it implies knowing more about chemistry, more about physics. It implies knowing more about technology. And to understand the origin of the first stars and how the universe evolves, it's going to allow us to understand how we came to be who we are.
Today we know that our world began with the Big Bang, which, following that one unique moment, gave way to time and space. The term Big Bang is now part of our pop culture and permeates TV series, movies, and even traditional Latin American music, as with the group La Cuadrilla, that composed a song dedicated precisely to the Big Bang.
Yo soy Fariel Labarca.
My name is Fariel Abarca. I've dedicated my life to music. I grabbed my first guitar when I was an adolescent. One day, a guy comes up to me and says that they are making a group named La Cuadrilla and that they were looking for a singer. With the cueca, our national dance, one discovers content like that of street life, marginal existence, injustice, the sorrows and hardships people go through. There's something very alive in the cueca, something underground, we might say.
La relación del arte, de la cueca, en su historia, en su
The
formación,
relationship between the art of the cueca, its history, its creations, and its origins, with astronomical contents. I mean, if the cueca is unknown, especially in its central style, to most people, even fewer know about this strange relationship of the cueca and folklore with astronomical associations.
relaciones astronómicas, con las simbologías de los astros, estas cosas cosmogónicas.
With astral symbology, with these cosmological things. And we put together a recording inspired by that topic. Only cuecas related to the astronomical metaphor.
Astronómica.
Y en su orilla
universe began with the Big Bang. But how and when did life originate on our planet? We travel to Spain to meet up with Ricardo Mills, a researcher who has dedicated his life to answering this question. Ricardo is one of the world's leading experts in Rio Tinto, an exotic location in the south of Spain that holds important secrets to the beginning of life. We meet with Ricardo in Madrid at the Astrobiological Center, where numerous experiments about life, recreating the conditions of our planet millions of years ago, are carried out.
Astrobiology is a new concept. The responsibility of astrobiology is to answer the question if we are alone, if life is a unique phenomenon that exists on planet Earth under circumstances that are exceptional, or rather, as we astrobiologists think, it's a global phenomenon that exists throughout the universe. So then, obviously, what we have to do is demonstrate this. One of the favorite places for astrobiologists is the Tinto River. That's because today, the Tinto River is the best geochemical analogy, meaning both geology and chemistry, that we have of Mars. There is life in the Tinto River, and moreover, as we'll see, the river is a product of life. Why is life capable of existing in places we recently thought were impossible? For example, miles beneath the ocean, under great pressure, or amid the extremely high temperatures of volcanic activity, or even under high doses of radiation. The lesson we have learned is that whenever life has a chance, it adapts.
We are on our way to the Rio Tinto in Andalusia. This river is known for its mining industry. In fact, mining has been going on for thousands of years. Numerous civilizations, including Abinos, Phoenicians, Romans, and Muslims, extracted minerals from this area. Our destination is significant due to its connection with the origin of life.
Estamos en la zona de Rio Tinto.
We are now in the area of the Rio Tinto. Minas de Rio Tinto is the town located in the province of Huelva, in the southeast of Spain. Minas de Rio Tinto is not only important for its mining, but it also gives its name to a peculiar 62-mile-long river that is red in color.
El color rojo que corresponde a su nombre, al nombre de Tinto.
The only important differences between the area of Rio Tinto and Mars is temperature. This is the only analogy that is missing. The rest, its geochemistry, its mineralogy, are identical. The minerals that are being identified on Mars during recent expeditions correspond to what we see in this zone. And the astrobiological interest exists because we know that many of these minerals are the result of the transformation of primary minerals due to biological activity, which obviously requires life, biological activity. And this opens a window that those minerals found on Mars are also related to biological activity. We are now at the halfway point of the Rio Tinto. The curious thing about the Rio Tinto is that for many years it was considered a dead river, due precisely to its characteristics: extreme acidity and elevated concentrations of heavy metals, and the fact that there is no amphibian life, no fish, no toads. So Mr. Burgo accepted the idea that it was a polluted river and that life here was impossible. What we've been able to demonstrate is that it is not a dead river. It's alive and owes its characteristics to the biological activity of those microorganisms. It is a microbial life.
The waters of the Tinto River are extremely acidic, containing a high content of heavy metals, mainly iron. It is a lethal habitat for many organisms, including human beings. Exploring these waters is like traveling in time to see how our planet may have appeared millions of years ago. The primitive microorganisms that live here and feed off the minerals showcase the adaptive qualities life has to survive under truly extreme conditions.
The type of work we do in the Rio Tinto has two branches. One that has been around for many years and that we know more about, the microbial diversity that exists in the river. And the other type of work, in which we are actively involved today, is a project named Ep6, where we are trying to understand the origins of the river. It is clear that a river cannot naturally form with a solution of 60 to 80 grams of iron per gallon because of sulfuric acid. This has to come from somewhere. Something has to create these conditions. And the most plausible hypothesis is that this comes from the subsoil, where there are elevated concentrations of the mineral that feeds these microorganisms. And that is what we have been working on, to learn what type of microorganisms exist in this subsoil. Most of the extreme environments surprise people. First, because we humans think life can only live under very specific conditions of temperature and pressure. The great revolution in biology came when it was rebutted. And these most extreme environments, very low temperatures, minus 85 degrees Fahrenheit or more in the Vostok Lake, or in the highest temperatures associated with volcanic activity, or geysers, or at enormous pressure, 5 miles beneath the sea, or under acidic pH, such as we find in the Tinto River, or alkaline pH, such as we find in certain lakes in Africa or California. Life in these places has no problem. It can develop. What we have learned here is that life, far from subtle and dependent on specific conditions, is capable of adapting to any condition. We are now at the origin of the Rio Tinto, where the concentration of iron is greatest. There can be a concentration of iron 1,000,000 times higher than found in the ocean. We have to keep in mind that iron is essential to life. There would be no life without it. And the curious thing here is to find concentrations of iron this high at the origin of the river. And this is what brings us to the question of how this came to be. For animals, this water is extremely toxic on one hand because of its pH, because it's acidic, and on the other because of the concentration of heavy metals, not only iron, but here we have the complete periodic table in a solution form. And basically too, because of the ions it holds. I mean that besides the heavy metals, it also holds sulfates. For humans, the most toxic, I would say, are the heavy metals.
Estamos en un lugar muy peculiar de...
We are in a very peculiar place in the area of the Rio Tinto, basically. The great difference that exists between this area and that of the river is that here we can find algae that stand out. The hypothesis is they probably like to live here because of the levels of iron in solution. It's also an interesting place because it allows us to understand how microbiology works. There is a hypothesis that sounds more and more reasonable, that life on Earth did not originate on this blue planet, but rather that it comes from Mars. As we know today, microorganisms are capable of traveling throughout space. And therefore, the option that life arrived on Earth from, for example, Mars, is not absurd. The hypothesis is that this life may have originated on Mars, just like on Earth, because billions of years ago, both planets were brothers. They were the same, at both geological and physiochemical levels. And recently, new evidence emerged that makes this more feasible. Scientists found the existence of minerals such as molybdenum and boron on Mars during the time when life on Earth was just beginning, elements which did not exist on Earth. So the possibility that life originated on Mars, that we are Martians, is feasible and is being discussed in scientific forums.
Could we all be Martians? Are we the clones of superior extraterrestrial beings that brought life to Earth? This is the eccentric belief of a group of followers behind a movement called Raëlism, a mix of philosophy and religion that has grown over the last few years.
My name is Antoinetta Muller. I belong to the Raëlian movement here in Chile. It's a group created to share information that extraterrestrials gave to Claude Raëlian. The Book of Raël is our guide. When I was born, my parents, who were Catholic, decided to baptize me. And since I didn't have a choice, I went to a Catholic school. I mean, I was raised and received a Catholic upbringing. And for me, when I read the Bible, I felt that it had a lot of uncertainties that just did not fit. The Bible, for me, didn't have the answers that I was looking for as a child. This God, this mystic God, some things just didn't make sense. I was introduced to the Book of Raël in April of 1999. When I read the Book of Raël, the first part contains a translation of the Bible's Genesis. It was here where I was able to find all the answers to those questions I had had as a child, as to how the earth was formed, and how we were created, and the connection we have with the universe as a whole. We, as Raëlians, understand that we were created by scientists on their planet, and they developed their science to a point where they were able to create humanity here on Earth. They came from a faraway planet and brought their technological know-how to create life here on this planet. They are similar to us, and as an act of love, came to this planet and created life, starting from the most basic life forms, like one-celled organisms, until they created man in the image and likeness of themselves.
While people have the right to their own religious or spiritual beliefs, from a scientific point of view, evidence of the origin of life on Earth point towards something quite different. It is probable that all forms of life, including ours, evolved from a common, basic, and primitive origin, which occurred some 3.9 billion years ago. A variation of this theory is that meteorites that impacted our planet could have perhaps introduced life. We travel to the Lucia Observatory in the Coquimbo region in Chile to meet Olivier Hanot, an expert comet hunter from Belgium.
A comet is big. We're talking about millions and millions of kilometers, and it's made of dust, and all this dust comes from a nucleus. From the nucleus of the comet, which is small, we are talking about 1 kilometer, 2 kilometers, a big comet, 10 kilometers. The nucleus is made up of a mix of ice and dust, and when it gets close to the sun, the nucleus of the comet heats up and the ice melts. More precisely, it sublimates directly into gas. And when the ice sublimates, it throws the dust into space, which begins to form the tail of the comet. Comets are interesting because they have always been there. They were formed at the same time as the planets, the formation of the solar system, and they've always been around the solar system, in the external zones of the solar system. It's like having little pieces of the solar system when it was created, left frozen for billions of years. This might also explain where the water on the Earth came from. We know that when the Earth was formed, it was dry. It didn't have water. So the water had to appear during Earth's history. It might have been chemical reactions between the atmosphere and volcanoes. It might also have been that it fell from the sky in comets. Since comets are made up of ice, if many comets fall, this may have filled the oceans.
No, gracias. Desayuno nomás. Je peux me joindre à toi? Son las 2:30 de la tarde. Los diurnos acaban de tomar el almuerzo y yo estoy.
It's 2:30 in the afternoon. The day shift is having lunch, and I'm on my breakfast. We work at night and sleep in the morning, so now I have a couple of hours to walk around a bit to prepare the night observations, and around 4, I'll be at the telescope preparing everything to start my observations during the sunset. The time changes from day to night is okay. You get used to it. It really depends on whether the observations are interesting, fun, then the night passes easily. If the observations are long and nothing much happens, if there are clouds, then at 3 a.m. you are dead tired. But after 2 or 3 nights, you get used to it. The work of the astronomer, the telescope observer, is a mix of very exciting things, where you're making discoveries in real time. You are seeing things that they've never been seen before. At the same time, it's hours and hours and hours where not much happens, and you have to be patient and fight off sleepiness. So there's a balance. All in all, it's quite interesting, quite entertaining.
El estudio de los cometas es interesante.
The study of comets is interesting because the comets themselves are interesting, to see how they function. They tell us about the history and formation of the solar system.
La historia y la formación del sistema solar.
Comets were formed at the same time as the planets, a little more than 4 billion years ago, and remain around the solar system all this time. In the cold, without light, without heat, perfectly preserved. And once in a while, suddenly, a comet arrives in the inner part of the solar system, where we are. And it turns on, it is activated for the first time, and gives us the chance to study this ball of ice that was perfectly preserved for 4.5 billion years. Main belt comets were discovered more than 5 years ago, and now, with all this data, we have learned a lot.
Los cometas del cinturón principal se descubrieron hace 5 años, más o menos.
It suggests that there is water in the main belt of asteroids, and that this is important for the formation and history of the solar system. It also suggests that there is water in the main belt of asteroids. And if there is water in the main belt of asteroids, this is like a zone in which, if there is water, it can fall onto Earth. And this would be a good explanation for why we have water on Earth.
¿Por qué tenemos agua en la Tierra? El agua de la Tierra tiene una importancia.
Water. The water on Earth is tremendously important for the appearance of life. We are made up largely of water, so if the water on Earth, our water, comes from the comets, it's a very direct connection with comets. The oceans are like comet juice, and we are the children of comets.